Logarithms are wonderful tools for getting the variable out of the exponent. But if the variables are not in the exponent, then frankly, I'd rather get rid of the logarithms. The rule I'm going to use is that the log base a of b is c is equivalent to b is equal to a to the c power. Here I don't have a single logarithm, so I'm going to try to combine using the laws of logarithms in reverse. The log of a difference, the difference of two logs is equal to the log of the quotient. So this will become the log of x plus 1 over x minus 1 is equal to 2. Using this rule, I know that what is on the inside, that's my x plus 1 over x minus 1, is equal to base to this power. Now, I don't have a base written here, which means that I'm using the common log, the log base 10. It's a log that's used extensively in science. So, I'm going to consider this base 10, and what's on the inside, the x plus 1 over x minus 1, is going to equal the base, that's 10, raised to this power. To isolate an x, first I'm going to multiply both sides by x minus 1, then try to gather all of the x's together on one side. I have x plus 1 is equal to 100, that's my 10 squared, times x minus 1. So x plus 1 is equal to 100x minus 100. I will now move the x's over to the right, the constants to the left. 101 is equal to 99x, so x is 101 divided by 99. There is a slight danger in these problems. When I move from here to here, there are times when I have original values which might have been either 0 or negative, and yet end up having perfectly good solutions down here. So if I plug in 101 over 99, I check to see if it's positive here. It is. And if it's positive here, again, it is. And so this is a good answer. Here I've got a very similar problem, except with plus. The sum of two logs is equal to the log of the product. So here I would have the log of this times that. Well, that's x squared minus 3x. Now I will use this equivalence to write the inside, x squared minus 3x, is equal to the base, again the base is 10, to the first power. That will be 10. Since it's second order, my strategy is to move everything over to one side and attempt to factor. This factors as x minus 5 times x plus 2. Now if I multiply two things together and get 0, one of them had to have been 0. So either x minus 5 is 0, in which case x is 5, or x plus 2 is 0, in which case x is a negative 2. I still have to check, are these numbers appropriate? Not here, they definitely work here. Are they appropriate in my original equation? If I plug in 5, I would have the log of 5 plus the log of 2. Both of those make sense. But if I were to plug in a minus 2, I would have the log of a negative, the log of negative 2, plus the log of negative 5. That does not make sense. Circle the correct answers, put an X through, or I tend to put it underneath the values that do not work.